Let us start.
Sure.
As we all know, today I have already shared the agenda with you guys. Tajudeen will start for the initial introduction, and then we have Saurabh talking about APIs, and then Sumit, and at the last it will be Abeer. So let's start. Tajudeen already shared his presentation, so let's start. Please, Tajudeen.
All right. Good day, everyone, and welcome to the second week of our revision class for SMP4. I will be speaking briefly to descriptive analysis, data mining, and web scraping. In starting, I will try and create some little context around descriptive analysis. Yeah, I hope everybody can see my slide. I hope everybody can see my slide.
Yes, yes.
Yeah. Yes,
Okay.
yes.
All right. First part of week 2 study was about descriptive analysis, introduction to descriptive analysis. In my own little understanding, I've said descriptive analysis is the preliminary stage of processing data that creates a summary of historical data to yield useful information and prepare data for further analysis. It is used to describe the basic feature of data in a study. And what does this mean? In data analysis, in descriptive data analysis, what we do is we gather data based on past event that has already occurred, that has available data. You put them together and you try to make sense of it. And in descriptive analysis, there are 3 major stages that are involved, according to my understanding and what I've read. And the first is you need to know your data. How much data do you have? And how much data is missing? So if you are gathering data together and you want to make sense of it, you need to know what is the quantity of data you have to analyze or to work with. And after that, you compute a range of frequencies for individual variables, depending on what you're looking out for or what you want to achieve with the data. And the last part, which is you have to examine the relationship among pairs of variables using crosstabs, box plot, or scatterbox, or whichever tools that you are comfortable with. So if you put all this data together and it shows you pattern, you can then say what you have found out about the data. What the data set that you have gathered, what does it speak to? What does it shows you? What pattern does it gives you? So in that stead, you will be able to make a sense of what you are doing. So is the preliminary stage, is the beginning, is what you have to do when you want to make sense of data that you have aggregated. Now, we speak about data mining and web scraping. I think this is the part that we're going to dwell more on. Data mining in context. What I've discovered is that a lot of businesses requires data, and data mining has opened a world of possibilities for businesses. The field of computational statistics compares millions of isolated pieces of data and they are used by companies to detect and predict consumer behaviors. The objective of this is to create market opportunities. So I will be speaking more to application of all of this, application of data mining, application. Like I said, oh, okay. Like I said data mining is a computational process of discovering patterns in large data sets. That is, process of analyzing large data sets to uncover trends and valuable insights. While web scraping is the process of extracting data from web sources and structuring it into a more convenient format. Now, a lot of people speak about, some people talk about data mining and web scraping, and they interchange it. They try to confuse the two together, but they are separate. They are separate mechanism in the real sense of it. Now, there are several ways you can apply data mining and web scraping, and they are different. Their usage is different in the real sense of it. And what I've put here is, I said, data mining. In data mining, you gather, you analyze the possibility, you analyze the data, and you put it in a meaningful pattern in order to arrive at a conclusion. And that is the major point there. You use it to, arrive at a certain outcome. When you do data mining, the aim is to use it to understand the patterns, and you can use it to forecast. But in web scraping fetches and passes web data, organize it, and display it in an easy to read format. In the real sense of it, you are gathering data. You are just putting the data together in the form it appears. So the data mining goes a little above that, in the sense that you can with data mining, you can arrive at a meaningful and concrete position or outcome from data mining. So if I want to quickly compare the two, I said in data mining, for instance, and I will give this practical example. And the practical example is, for instance, if a business were looking to match prices. If you have a business and you want to match prices, for instance, if I have, let's say, TJ Zone, and I'm looking at Amazon, I want to know the prices on Amazon website, because I want to use it to judge the price I should give my own products. Now, what I would do with data scraping is, I will go to Amazon site, I will look at the range of product that Amazon offer that I have. I will extract prices of those products in the raw form they have. For instance, if a bottle of wine is being sold at Amazon for $1,000, or and high glasses is being sold for $500, I can go to Amazon, I will obtain all this information, and I will use it to determine the price I want to set my own prices at. Now, in order to continuously use this information, I need to constantly go to Amazon page to go and be extracting the prices at every point in time that I'm putting up a product out there. I need to constantly go to Amazon website to go and scrape the data, look at the kind of the pictures, products they have, different types of wine, the prices they've given those wines. So with that, I can now say, okay, Amazon is selling it for $1,000. I want to sell it for $950. Amazon is selling it for $800. I want to sell it for $700 or $750 or even $850. So with that, that is what web scraping does. It goes there, take the data, dump it, and you can use it to form a decision. So but with data mining, what data mining does is, data mining will go to Amazon, take historical data on prices they've set in the past, put it together, and use it to predict their future prices. You can see the connection between the two. So with web scraping, you go there, you take the raw data that is there, the prices and everything, you use it to inform your own decision on how to set your price. But data mining goes historically, 2, 3, 4, 5 years ago. Look at the trend, look at the patterns. How do they set their prices? How can I put those data together to predict what their future price will be? That is what data mining is all about. So data mining will gather those data, analyze it, use it to predict behavior, use it to predict behavior, use it to know how Amazon set their prices. Oh, every three months, they change the formula they use in doing their pricing. Every three months, they either increase or decrease their prices. They change their product type every three months, or they maintain the same type of product over a long period of time. Data mining will help you in order to achieve this. But with web scraping, you just go there, you take the raw data, you know the prices, you know the product they always sell, and you can use that to know what product you want to put out there, what prices you want to sell them. But data mining, it gives a detailed analysis. It gives you the opportunity to put all those data together, analyze them, and use it to form your decision over a long period of time and to predict. So that is what data mining is. Now, I said the difference between data mining and web scraping. And I ask a question that what do we think? What is our own opinion about data mining and web scraping? So I said one of the major differences is on how they are used, how the data are used, how data from data mining and web scraping are used, and how they are used in the everyday life. And I said data mining is used to see how different websites are connected with each other. For instance, if you look at Uber and Karim, they take data from two different sources. They use it to predict what expected time of arrival of a user will be, and it gives them accurate data. It gives them accuracy. So you can look at that. It's a predictive model. You know, you've taken the distance. You over a period of time, we know how long it would take from, let's say, London to Cambridge or Cambridge to London. You take the data from two different sources and you use it to predict, to predict expected arrival time. Why web scraping is used for varieties of purpose, e.g. financial or academic research, data collection, and about competitor to boost sales. So that is basically what that is. Now, in your own opinion, as colleagues, what do you think? Do you think data mining and web scraping perform the same function, or do you think they are the same thing? So I would like to listen to your thoughts around this before I continue further.
I think, hi everybody. I didn't say hi before. From the way you explained it very thoroughly, actually, I think they are complementing each other to some extent, rather than being identical. They are needed in different phases or to complete the facets of each other.
Okay, thanks, Abeer. Thanks for that. Any other thoughts?
What I understood is data scraping is the activity which results in mining, in data mining. So data mining is this collection of data, and data scraping is how you would do it. You would, go through the internet and scrape for data.
Thank you. Yeah, valid.
Actually, my understanding is a little bit different. Web scraping is just a data that is available on website. Any of the website that you go and find that data, that is called web scraping. But data mining is more deeper. For example, there is a data available in a database or on a server of Amazon, and you are getting that data from the database itself. Either this database is maybe on satellite, this database could be on any of the server, or it is on the cloud, but you will get the data from the database itself. It's a very huge data that is called data mining. But if you are getting the required data from any of the website, that is web scraping. This is my understanding. I might be wrong.
Yeah, I think I'll just add a point to what Mustafa said. I think, as the name says, web scraping, it itself explains that you scrape the web, and whatever information is available, publicly available, you extract the information through crawlers or bots that we learned in the session. Now, if you want structured information for any sort of application, or to integrate that information in your application, I think that is where you actually take the routes of data mining, wherein you gather information through APIs and then integrate that information in your platforms. And that's when you mine the data. So mining, in my understanding, whether it is through web scraping or whether it is through APIs, I think data mining is a broader concept. When we say mine the data, or when we say text mining or data or text mining, you mine the data. Whatever data you have gathered, how do you use that information? How do you integrate that information? How do you derive more value from that information? How do you embed that information in your platform is called data mining, which
Yeah.
is mining the data in terms of extracting more information from the data that you have gathered.
All right, thank you so much. I intentionally created this venue for us to have this little discussion because even in the lesson video, I saw the lecturer mistakenly using data mining and data scraping, interchangeably. So when I was researching for this little discussion, I realized that there are two different concepts actually. Web scraping, like I explained in the case of the Amazon and my business. For instance, I have a wine, or I'm opening up a shop and I want to fix prices for my product. I can go to Amazon, scrap Amazon website for their prices and list of products and apply those prices or use that information to set my own prices and the product I want to sell. But at the same time, if I want to do data mining, I go to Amazon website over a period of time, maybe 3 years, 4 years, I take historical data of their prices and product that they've sold in the past. And I use that to predict what their next price would be in future. And I can use it to set my own price. And I can use it, I can discover what product they've done away with that they are not selling again. Maybe because of low patronage, maybe because of the shelf life. It stays longer on their shelf and they drop it that people are not patronizing it very well. So if I take those historical data, I can match it together and analyze it and mine it further in order to predict what time should I be changing my prices, what time should I be changing my product, what type of product should I be selling. But with web scraping won't tell you this information. Web scraping will just give you raw information that you are obtaining from Amazon website. So that is a bit of the little difference between them. Thank you. So the next one is the legality of. Now, from the lecture note and from a little research, web scraping in its entirety is not actually illegal in some instance, and in some instance it could become illegal if you are not taking cognizance of the little details around it. And what could happen? Now, like I said it's not entirely illegal. And where there are copyrights, where some data are copyrighted, it is illegal to copy those data and use it verbatim. But like in the lesson note and a little bit of research, facts, things that are facts, that are generally known to be fact. Once, if you scrape those data and you use it, in the real sense of it, there are no legal implication, in as much as you don't present it in the same way the website has presented it. For instance, I might say Cambridge is always 45 degrees centigrade every morning. If it is 45 degrees centigrade every morning and it's a fact, and I put it in a picture, in an embedded picture, in a loft shape format, and I present it with a certain color, yellow, and I put it on my website. If you are obtaining that data, if you want to use it, you cannot copy it verbatim the same way I've presented it and use it on your website. With that, what you have done is you have copied my intellectual property. The intellectual property there is not the content. It's not the content of that stuff that you have copied from my website, but it's the mode of presentation of that content. So that is the fine line. That is the thin line between legality and illegality of web scraping. So, like you said, the appearance, the looks, you can modify it. You can copy the content and use it. But things that are not copyrighted, there is no legal implication into using them. And another side to that is, according to the Lexidot as well, it said any web scraping activity that you would do that will have side effect on the business that you have copied, you have scraped those data from, it can expose you to legal obligation. For instance, if you set a bot to scrape my website, and that bot is creating some artificial traffic on the website in a way that is affecting the performance of my website, I can put up a legal action against you. But if nothing of such happens, there is no way you can claim that somebody is affecting your business or impacting your business negatively, with their activities on web scraping. And of course, because of the thin line between legality and illegality of web scraping, a lot of companies are looking for a way to prevent people from copying their data, from accessing information on their website. And there are, in doing this, they've put up different ways of preventing people or web scraping activity on their website. Now, how can we enforce the website terms of use and service? For instance, in the lecture note as well, it's stated that if you log in to a website and you click on accept terms of use and condition, then there is little or nothing you can do with information that you are gathered or you are scraping from that website, except with express permission, or except if the terms of use of that website allows you to use the content of that website. Otherwise, if the terms and conditions of use of the website does not permit that, then you might be exposing yourself to legal battle. Now, if you don't have to log into that website and you have free access and everybody can access it, then any activity that you do with the content of that website cannot be exposed to any legal children, because the implication of that is you can actually use bots to scrape those data and it won't have human footprint on it. So you can use those data as you like. And the third phase is if there are pop-ups. For instance, you don't log into a website, but when you click into the website to carry out your activity or to scrape the website, if there is a pop-up that says accept terms and conditions, and you click on accept before proceeding to that website, then there is limited use to the content that you can put the content of that website into. So we need to be extremely careful in the way and manner we use content of website that we have had restricted access to. Now, this at the back of our mind will be begging for a certain question that if I web scrape, am I committing an illegal activity? Is it legal? Is it unethical? To me, personally, web scraping is a requirement for business growth. It's something that you need in order to take your business to the next level. So the way and manner with which you conduct your activity around it is what differentiates you from illegal activity or legal activity. The last bit of this is the litigation, which I've spoken to largely, is the litigation around web scraping activity. I said when it is proven that scraping activity affects businesses, it can be a good ground for litigation. So companies, like I said earlier on, has different approach, different mode with which they've restricted people from scraping their website or from having unauthorized access to their website and their content. Some of this is blocking the range of IP addresses from accessing the website, blocking of user agents, e.g. the bots, for like we all learned, Google, for instance, and some other search engines, they use user agents, web agents to, you know, to scrape thousands of websites in order to provide or to return results for people that are using those search engines. So what some people have done is anything that carries bots, they can intentionally block those bots from accessing or scraping their website. Using capture challenges, I'm sure we've all encountered this. In some instances where we'll go to a website to perform activities and we would have logged in and put everything, and it will ask us, are you human or not? Some today, because they don't want, they want to improve the user experience, they won't put the captcha for you to type or what have you. The question is, are you human or bot? Once you click on human, it will allow you free access. It believes that there is somebody behind that activity, and that is why the person is able to click that I am human, and it gives you access. Some, they will use alphanumeric character for you to type in, just to perform the activity. But in today, maybe for our individual organization, I think the fastest and the one that promotes effective user experience these days is the one that we ask you, are you human or bot? Once you click it, there is an activity, and it's that activity that really matters. So that's another one. Using of image to display crucial content such as email addresses, telephone number, address of organizations and institutions. Those are some of the things that are being used to what's it called, to discourage people from scraping a website. Again, another critical one is change of website display. If you look at most websites today, if you want to copy their contact details, it says contact us. Once you click on contact us, you will see the addresses, you will see phone numbers, you will see email. Some people, what they are now doing is, if you click contact us, you won't see you won't see the email addresses or phone number. But if you click about us, the first line of information they give under about us might be their phone number, their email addresses, and contact persons. So if you interchange those things, by the time the bots come to your website, the first place the bot is going to search for those information is under contact us, because that is the norm. But when they get there, they might not see it. So those are the things that some people, some organizations have actually put in place to discourage people from scraping their website. Okay, so let me quickly speak to some of the uses of web scraping, where practical application of web scraping. Number one, we said we scrape product details, which, like I mentioned earlier on, price, image, rating, reviews for retailers and manufacturers, from retailers and manufacturers' website, in order to, you know, improve our own competitiveness, and in order to determine what range of product we should be putting out there. We scrape property details and agent contact details from real estate websites. We scrape people's profile from social media networks like Facebook, LinkedIn, in order to track their online reputation. We scrape hospital and clinic websites. We scrape reviews of products and places. And again, we crawl on forums and community to extract data from posts and authors. For data mining, some of the uses of data mining in the real sense of it is number one, you can mine a data that shows consumer behavior. For instance, if I'm someone that if I subscribe to a lot of social media or website, and I have the tendency of opting out every 2 weeks, if there is a data that shows my propensity to opt out of those websites constantly, if you gather those information over a period of time, then you can use it to inform or to predict my behavior on future websites, that, oh, if I subscribe to this, in the next 2 weeks, in the next 3 weeks, I will opt out. And you can use it to predict consumer behaviors as well. Who would default on loan? who would default on credit, who would another thing for data mining is you can use it to predict, for instance, in a supermarket, if I come into a supermarket all the time, or a group of people come into a supermarket, and the product they buy every time, you can use it to gather and aggregate those data and use it to predict how you should structure your aisle in order to arrange, products that if A buys this product, it will automatically buy B or C. So you can use it to predict future behavior of consumer on the shop floor. So some of these things are the uses of data mining and web scraping. So in conclusion, I would say this, that web scraping and data mining is fast becoming the blood of business, and it will give you a real mileage and opportunity to to progress in your business endeavor. Thank you.
Thank you, Tajudeen. Thank you for your presentation. And I think now we'll go to the next topic. Saurabh will be taking care of it. So Tajudeen, can you please just stop your screen sharing? So Saurabh will start this.
Thank you, Tajudeen. It was very constructive, very rich. I highly appreciate your inputs.
Thank you, Abeer. Thank you.
Can you all see my screen?
Yeah, you can see it.
Yeah, we can see it.
At
least I can.
Okay, so thank you. I have been tasked to talk about APIs, which is sort of a technical subject. Well, I'll try to do justice based on my knowledge and understanding about APIs. But before that, thanks so much, Tajudeen. I think you managed to capture a lot of information in one slide around data mining and web scraping. So as we heard from Tajudeen, I think data mining, as I mentioned, is a very broad concept wherein it actually speaks about collecting data through different mechanisms. One certainly is web scraping, wherein we scrape the web and different websites to gather information, whatever is publicly available. But certainly that does not have a lot of flexibility, and you cannot get detailed information about data through web scraping. And for that, I think APIs play a very important role over there, because APIs provide a very structured mechanism to get information and data from external platforms or databases. So I've tried to capture the definition of APIs from different sources. APIs is actually an interface, as the name says. It's an application programming interface. It's a way to connect to an external database or an external application and get information or data or results back in an agreed format. When I say agreed format, something which the computer can read. That's the simple definition of APIs. Another definition is that it's a sort of a messenger. APIs, it's actually not a application, it's a messenger wherein you send information to an external provider or a database or an application that you need the information in this format, and the supplier or a provider provides you that data in that format. The point number 4 that's mentioned on this slide is my definition, wherein I say that APIs facilitate a faster and easier process to source data from an external database and platform. And it actually helps us to help the user or the application to process large volumes of data quickly and efficiently, and helps the user and the application to extract and integrate information into their own platform or application. So that's the definition of APIs that I wanted to share with all of you. Now, before I share with all of you the use cases, I'll get into little bit of technical information in terms of how does this whole thing works, what exactly APIs are, and what is the format in which we receive the data from the provider. So these are a few key things that I wanted to share on this slide. One is in terms of, as I mentioned, APIs is not an application. APIs is an interface. So how it works is that APIs is a set of specifications. For example, it's a request message that you send to the provider. So for example, if I say I am asking for some information from, let's say, YouTube. So YouTube has an API key through which I can ask information on particular elements. And I'll talk about it a little bit more in the later slides. And I'm asking information in specific format. When I say specific format, I want the data either in a JSON format, or I want it in XML format. Now, these are the language formats. So when I say about JavaScript, I hope all of us have heard about JavaScript. This is a most commonly used data language. It's actually an open standard file format, and it uses human readable text. But if you move to XML, which is also a sort of a commonly used language, this is a markup language wherein this format uses both human readable and machine readable text or formats. So these are the two formats in which the data is received from the provider using APIs, or the provider extends the data in these two formats to whosoever has requested for the information. Now, one of the other thing that I also wish to share with you is around metadata, and this is a commonly used word when we are talking about large volumes of data. And what it actually means is it actually describes the format of the data. So for example, if you look on the last statement on this slide, it actually explains the format in which I need the information from the provider. So for example, if I'm asking from the provider that I need information about an individual, when was this information created, when was it modified, and other related information. All this information, the structure of this information is defined as metadata. So this is slightly technical, but I thought I'll actually share this basic information with you around APIs and the language that is used to deliver the data. Now, I also picked up certain.
Sorry, can I interject? Sorry, just a quick question before you start the next slide.
Yes.
Saurabh, I wanted to ask, you mentioned JSON and XML are human readable. XML is partly human readable, machine readable. How do you define human readable or machine readable languages?
I think Sumit, that's a good question. I also don't have very detailed information on this or knowledge about it because I'm not a technical person.
Okay.
But I could understand is that XML, generally people use XML because it's both human readable and machine readable. When it comes to JSON, I think the flexibility over there is that it's an open format. So even if it has to be manually processed by a human, this can be used. So,
right,
so
yes,
a human can.
I've seen JSON files there. It's actually like a notepad file written in plain English.
Yes.
I'm not sure if I've seen XML files, but I wanted to understand. So languages like C++, etc. Would you call them human readable, or would you call them, so any language which a human can learn by reading a C++ manual, will that be called a human readable, or any layman's language would be called, like English is a human readable, or is C++ human readable?
No, I think whichever the human readable uses a human readable text. So I'm not used C++, so I am not an expert in that. But I believe that if humans can actually use it to read what the content is, and if that's true for C++, I think then it should be termed as a human readable text or human readable whatever format.
Can I add one point
All
here?
right.
Actually, as per my understanding, human readable and machine readable. Human readable, any language that human can by it understand it. Machine readable, always it is a binary. It is 0 1. It, you cannot under, a human cannot read it. It is at the back end. It's working in binary in format. It's 0 1 0 1. Everything that is in the machine, that is stored, any data, either it is a picture, it is a video, it is whatever it is, that is in the binary. That is the machine readable. This is my understanding about human readable and machine readable.
Yeah.
I think we can
Yes.
still read binary language to an extent. It's, I mean, for humans, we can translate it. It will take us time. So that was the question. Like C++ is also readable. You can read the transcript and you can translate it to a layman. And binary, again, same. I can translate it to a layman that this is talking about a table or it's talking about a picture. But what I wanted to understand is, I mean, this is something maybe we all could do a bit of research and let each other know about this.
Yeah. But that's a good question. I think that this is something which I'll further explore. Okay, so moving to the next slide, I also looked at in terms of while we went through all the application, and I'll speak a little bit on the applications later in the slide. What I actually gathered is in terms of what are the broad benefits or the advantages of web APIs. And if you look at the right side of the slide, you'll see an infographic. Now, this is an old infographic which I picked up, and it beautifully captures information about APIs. It defines what the APIs are, how do they work, which industries are using APIs, which was the first organization which actually opened up their APIs. And I was surprised because this was new information to me. It was actually salesforce.com. They actually opened their APIs in 2000. And I think I've added a link over here. Please do visit the infographic. It's very useful. It provides a good view in terms of, as I mentioned, all the information around APIs, how it has evolved over the period of time. Now, in terms of benefits, I think there are a lot of benefits that the web APIs have provided to developers and also platforms. Number one is certainly automation. Through this, we have managed to gather large volumes of data, which the computers can process rather than people or human doing it manually, which actually has helped to speed up the whole process. The applications have been very broad, as a result of which the delivery of services and information has been more flexible. The scope has further widened because there has been large volumes of data that can be gathered through APIs, and then it can be applied on the existing information that is available on the platform, and then you can further customize this to distribute your information and services. It's very efficient because it's automatically processing large volumes of information. Integration is important because what we have seen is that APIs have facilitated the process to gather a lot of information, large volumes of information, and then further integrate into the existing application in the platform, which has helped us to help the platforms to improve the user experience. It gives the flexibility of personalization because through the web APIs, companies and platforms have been able to customize their content and services and functionalities. And at the same time, I think there is also an element of agility, wherein APIs help to process information, but at the same time also anticipate changes. And that's why I think this has helped organizations to bring that agility in their services and functionalities that they have on their platforms. So these are some of the benefits that I could gather on the web APIs. And I also looked at the use cases of some of the platforms and some of the APIs that these platforms extend. So I'll start with Twitter. We learned that there are 400 million tweets per day on Twitter. That's large volumes of data. And what the APIs help is that through the Twitter APIs, you can download tweets from a particular account or tweets on a particular subject. For example, tweets on COVID, or for that matter, Donald Trump. I also looked at in terms of why people would like to do this. And I could find 3 use cases. One is in terms of analyzing information. So maybe the market research agencies would like to analyze insights on the users, market movements, emerging trends on a particular topic, on a particular product or a particular industry. I also found that Twitter provides APIs for their content, which is used by institutions to engage with audience. So one of the use cases wherein platforms or web platforms integrate Twitter content and features in their website and application. So if there is some relevant information around emerging trend, or for that matter, industry or a product or environment, platforms would use Twitter APIs to integrate the Twitter content or what people are talking about on Twitter on those particular subjects and integrate into their websites. And the last bit which I could find on the Twitter platform, on the Twitter APIs, was in terms of engaging with creating application that can engage, have a human-to-human conversational experience. So these are the 3 use cases that I found for Twitter and understood that how some of the organizations are embedding or integrating content from Twitter into their own applications or platforms. I also looked at LinkedIn and YouTube. LinkedIn, if you recall, we learned that LinkedIn is not a good place when it comes to getting information via APIs, because people can't share the LinkedIn data through APIs even if they want to. I think it doesn't provide that functionality. But there are other use cases of LinkedIn APIs, which I could gather. For example, I'll start with the third one. You would have actually observed on some of the job portals, when you actually apply for a role, it actually gives you a functionality that you can apply with LinkedIn. That is happening because of an API. It gives you an option that apply via LinkedIn, and that's where the job portal has actually integrated with the LinkedIn platform through APIs. Likewise, LinkedIn also has API-based services for measuring and maximizing sales performance. It's a similar tool like Salesforce. So they have also developed functionalities wherein they used APIs to enable and demonstrate sales performance through various dashboards. And then at the same time, there are consumer solutions also, where the APIs facilitate to extract information or collect information and then integrate on the LinkedIn platforms. YouTube, we learned that there are 4 billion hours of videos watched in YouTube each month. So that's a lot of information. What I could gather in terms of the use cases, why anyone would want to use YouTube APIs to collect information. And I think during the module 8 or module 9, we heard about the research that Professor David Stilwell did, wherein he looked at the Facebook likes. I think something similar is also on YouTube, because you can actually go to YouTube to gather information on the who's on the videos which have been liked, or who has liked which video, and for that matter, what are the comment threads associated to a particular channel, who's liking which video, which sort of region is liking a particular video or channel a little bit more. It also provides a API to retrieve playlist created in a user's YouTube channel. So this information is also something which YouTube provides to through its APIs. But I believe this is more used by again, marketing agencies or market research agencies to really look at in terms of who's actually viewing which kind of videos. And one of the most common use cases certainly is Google Maps and Google Translate. I think all of us, it's a part of our lives, and we use these functionalities on different platforms. It's actually, you'll find on different platforms, whether it is a hotel website or it is let's say a tourist attraction, or it is even on the public websites, the government websites, our organization websites. What it actually does, it converts the address into geographic map coordinates, but also at the same time it helps to calculate the route between the two specified points, and the distance matrix API actually calculates and shares with you the time required to travel between one place to another place through the various travel modes, be it walking or be it by car. And Google Translate is also an important, useful tool, I would say.
Saurabh, I have a question here. So
yes.
This API is calculating this distance, or the Google Map itself is calculating this distance?
No, I think the way it works, based on my understanding, is, so for example, I was looking it to understand a little bit more. The way it works is, I went to a tourist attraction in Singapore, their website. So I looked at their website, and over there, I checked in terms of how they're using the APIs. How are they using this functionality? So the way it works is actually they have this functionality on their platform, wherein if I click over there in terms of how do I reach to your location, yeah, what it does is that it's actually integrated with the Google distance metrics API, the Google distance functionality and Google Maps functionality through APIs. So what they have done, they have actually licensed with Google, wherein whenever I as a user goes to their platform and clicks that I'm staying, let's say in Eastern Singapore, and I want to come to your location, what it does is that it actually sends that information through the APIs to this platform, and that actually sends back this information that this is where you are based on the map coordinates. This is the distance. If you travel by car, this is the route, and this is the time that will take to reach to this location. And I think as we also learned about the UPS Orion platform. I think that was an example which this is also used the same approach.
Mm-hmm.
In terms of calculating the distance and the time required to travel between two specified locations.
Okay.
Does that answer your question?
Yeah, sure.
The Google Translate, I think I was talking about Google Translate. This is an application which is very widely used these days, because when people travel, there are language differences, issues, and it helps them to translate or convert local language into their language, be it English or any another language. And also it's embedded. So for example, it's embedded in LinkedIn. So you can see that when you have a new post on LinkedIn, which is in a different language, there is an application which says that translate. So when you click on that, it translates into English. So that's also happening via an API. Now we had an assignment in terms of what data could we find. I'll quickly run through you what I submitted as a assignment because I know we are running out of time. So I'll share this with you. One sec. Okay, so I'll not go through this the entire Excel file. I'll share this with all of you separately. But what I picked up is that actually I picked up five platforms. I picked Twitter, LinkedIn, YouTube, Google Travel, and Google Geocoding. I picked these five as part of my assignment, which I submitted. And I'll quickly run through a couple of things that I discovered while completing my assignment. I'll pick Twitter and I'll talk about that. So when I looked at Twitter developer website, the data is, the question was whether data is freely available. In most of the cases, what I found, data is not freely available. Even in the case of Google, the data is not freely available for the developers. Even for the APIs, you have to enroll, you have to give your account information, you have to go through an authentication process, and there is a cost to get information. In case of Twitter, there's a basic version which is free, but then there is premium and enterprise paid subscription. You have to go through a authentication process. There's permission required. There are limitations in terms of how much data you can actually gather through your APIs, through the APIs, because there's a limitation in terms of how much can you gather within a period of 24 hours. Then I already talked to you about shared with you the use cases. And there was a question that, are there any restrictions? And so I looked at in terms of the governing principles on the usage. And it's very standard. I think it clearly says that you have to use the data for the specified purpose, which means that whatever whatever use case that you have mentioned in your request, you should only use it for that purpose. You cannot use it for any other purpose. You cannot sell my data. You cannot actually involve a third party. So this is clearly defined in the terms and conditions. Whenever a data scientist or an organization requests for information, they have to sign or they have to enter into this agreement.
Saurabh,
So
I have a
that's,
question. Do you have idea what is the cost on different enterprise level or one user level on Twitter that you mentioned? Any
I could
amount?
not get for Twitter, but I got for Google. So for example, I got for Google is that the data is not freely available. Once the developer creates a billing account and the project you are eligible for on the platform, there is a free trial for a month, but then there are charges based on the usage. Now, for example, if you look at Google Travel, it is based on elements. Now, element is origin and destination request. So one destination request is one element. So it's based on that. If in a day there are 100 elements per client side request, it's charged basis that. So various platforms have various payment modules and the way they charge their customers.
I'm just trying to chip in over here to answer the question raised by Mustafa. I have the rates for Amazon, the marketplace website that they have in Europe. For that, they charge approximately £25 per month per marketplace. So, which means £25 for UK, 25 for Italy, for Spain, France, Netherlands, etc. And the otherwise, the API connecting the API is free, but this is the fee that you have to pay per month to remain active.
Okay, so that was there. I also had looked at and my own organization. This is my last slide, wherein I looked at in terms of how we extend API or our content to our users through APIs. We have a API program. We have a developer website wherein our users can actually come to the platform, request for APIs, request for content, go through the process. And if the user is from an institution which is using our solutions, the API, the content is free or the APIs are free. We don't charge for that because it's for non-commercial purposes. But if it is a commercial purpose from a corporate group, then certainly there are charges for that. So just briefly in terms of, I looked at in terms of how we are using APIs to extend our content. So that was my last slide. I hope it was useful. But again, as an expert in APIs, this is what I could gather through the learnings that I have picked from the modules, and also looking at in terms of my own organization, how we are using APIs to extend content to our users.
Great.
Thank you very much, Saurabh. It was really condensed. For me as a doctor, I know I am not as savvy as you guys, but a lot of good information. Thank you very much.
Thank you. Thanks, everyone.
So it was really nice. I mean, got real insight into it. Too bit technical, but yeah, still trying to make my head around it. But yeah, it's really nice. I have the similar subject tomorrow, so it's rather like very simple. Means I'm just like going over the water. It means you have taken a deep dive, so I will not do that tomorrow. But yeah.
Well, I cannot join tomorrow, but I can share my slides with all of you. If you want to use the slides for tomorrow's session, please feel free.
Please, Saurabh, we would definitely love to get your slides, and please share us even I think through WhatsApp. That is, we have a group. So now we'll move on. So Somit will be talking about next topic.
Yeah. Thank you.
Great. So I just need to figure out how to share my screen. Any advice will be appreciated.
There is one button at the bottom, share screen.
Share screen.
Okay, got it. Yeah, thanks. Great. Hold on. I think I got the wrong template out. Are you guys able to see APIs and statistics?
Yeah.
Okay, great. So the topic I have for presentation is not very technical. It's something that most of us would have already studied sometime in our bachelor's or master's degree. We're talking about statistics, APIs and statistics. So specifically, I'll be giving you a little bit of information on Amazon. We specifically deal with Amazon, and we're currently in the process of building an API and getting into the Amazon ecosystem. So just to let you guys already know about this, Amazon mandated, in fact, Jeff Bezos made it compulsory for all internal divisions of Amazon to use APIs for sharing, accessing data within the company, which means that if the HR department wants to get some information from the sales department, they can't send an email, they can't call someone or text someone. They will have to have an API. Through the API, they will get the data from the other division. One thing that Saurabh probably also touched upon, and I would like to reiterate, API is like a login ID and password. You use an API to request data from Amazon or Google or Twitter, etc. API is not a software. API is not a application. It's you can consider it like a lock and key, like a login ID and password. You have to request a key from Amazon, and Amazon will approve you as a API merchant or an API token holder. Secondly, Amazon also offers data to its external users, people who are not employees of Amazon. But again, this has to be done through an API. So this is, our company is an external user, and just like an internal employee of Amazon, we will also be pulling up data from Amazon through APIs. And I think the most extensively used Amazon API is probably the MWS. This is my personal opinion. I haven't been able to get any answers from my Google search, but because I think Amazon as a seller, as an e-commerce operator is probably the biggest giant in the world, I think Amazon's marketplace API is probably also the biggest API in the world. Maybe Google might be very close, or maybe Google might be number one and Amazon might be the second most busiest API. The MWS API is actually, it's called Marketplace Web Services. Also, Amazon e-commerce sellers would use MWS to pull data from various Amazon portals. So this is something that I've already touched upon. Data cleaning. So once we establish an API with Amazon or Twitter and we start pulling out the data, not all the data will be in readily usable condition. Amazon might be giving data in its own format. It might have 56 columns in the Excel sheet, or whatever format they provide. We probably will not require all that data. There might be duplication in that data as well. So the first step that you do once you receive the data is to clean the data. Initial step, to sanitize the data before it can be processed. An average, and this is a statistic, I think I read it in probably our module itself. Average data scientist spends about 80% of their time in just data cleaning and 20% in actually doing the analysis work. What are the issues you can face? Well, when you're cleaning the data, there will be duplication, there will be missing data fields, text can be in the wrong format, dates can be in the wrong format, time can be in the wrong format. Every data cell might be shifted one cell to the right, and that will screw up the entire table itself. So it's basically very basic sanitization, very basic housekeeping rules that need to be followed. And because it's a very generic, it's a task which is the domain, the kind of work that we need to do is, it can be anything. It's difficult to have a set manual or a do's and don'ts kind of a sheet for it. So there is no exhaustive or generalized checklist available. Each data set will vary and have its unique sanitizing requirements. Please feel free to ask me any questions in between, although this is not a very technically driven presentation, but if you still have any questions, I'm happy to answer in between. So now we've acquired the data from the, yes, please.
Sumedh, I'll just add a point for everyone's understanding. One of the challenges with the data scientists face around the categorical data is the names, specifically Asians.
Right.
For example, Sumedh, I'm using your reference, so please forgive me for that. Sumedh's last name is Sajdev. Now in India, you will see that people also add a towards the last as Sajdeva. Yeah. Mine last is Sharma. We'll have people who you don't use a in the last, which is they only write Sharma. They don't use last a over there. So there is a lot of errors when people upload their names on a particular platform, and that requires a lot of cleaning. So I'm just giving you an example which we also face, because there are so many overlaps in the names and so much of duplication which requires sanitization.
Right.
Actually, yeah. I was thinking before this program, I was thinking to just make a call and talk to Sumedh and ask him how to pronounce his name, especially the second part.
Okay, so the second part is you can pronounce it as such Dev.
Yeah.
I'll tell you, just share my experience with regards to the name. So for quite like around 6 years, I was based in Moscow. And the names are like, it was like really a nightmare. Now, there is a one named, say, Alexander. Now, the person may have Alexander, they will call him Alexander, or they may call him Shasha. So it's all three are same name. And initially when I started working, okay, there were the payroll sheets used to come, and everyone means as a part of my setup thing, I have to like verify that who are the employees. So there were like 300 people working, and verify like, okay, who are these people? And as it was like the initial phase, it was just like 6 months there, we started the operation. So things were not so systematic, like employee code and all those things were not so systematic. So it was a task for me, because every time the store manager changes, the previous one is using Alexander, the next one will use Shasha. And then I'm scratching my head, man, this guy new have joined, and we have not issued a joining letter from where he came in. And then I asked this guy, oh no, this is our old Alexander. No, but the name changed. No, no, we call Shasha. Alexander is same as Shasha. So it was really, I mean, it's crazy. And it's like different cultures, different name. Here also means in Dubai, when we use, say, a person have his name, then father's name, and then his family name. So sometimes they will just say Muhammad, or sometimes they will say Hamid Muhammad, and sometimes they will say Hamid Muhammad Rahman. It's like you cannot find out, like, is this the same person, different person, or how it is. So just the usability. Yeah.
I think that's a very appropriate example, Saurabh and Dhirendra. I've come across the same situation. Although I was doing nothing associated to machine learning or AI, I was just auditing some accounts, and the kind of data it would have names in it, it would have date of birth, etc. And these were the kind of problems we used to face. Right. So now we've acquired the data through the API. We've cleansed the data. We've taken care of the duplication, etc. Now we're actually going to start the process of analyzing and conducting our core job. But before we can actually put it into the machine learning or the various other tools that we've developed, we basically want to understand what this data is. We want to have a very high level knowledge about it, not at all in-depth knowledge, because that's what the machine learning will do. We just want to get to know, what is the distribution of the data, what kind of data set are we dealing with. So this section, the descriptive statistics or the summary statistics, is what will deal with this question. Descriptive statistics forms the groundwork for performing advanced machine learning or whatever other analytical tools you're going to implement. As the name suggests, this statistical representation of the data will describe and help the data scientist in understanding the characters of the data set. And I've primarily defined 3 different tools that you would use under the descriptive statistics or the summary statistics methodology. You will want to understand you will want to have a measure of the central tendency, or you can and the way you can do it is by mean, median, mode, average. All those, you've probably read about them in the past. Second is measure of variability. So standard deviation, variance, minimum or maximum variables, skewness, kurtosis. These are some of the terms. Again, most of us have already seen these before. And the third one is graphs and charts. So graphs and charts I think they can also be, they would also fall in either of the first or the second category, because the bar graph can also show you the mean and the median and mode. But at the same time, bar graph can also give you the frequency of the data, it can also be about standard deviation as well. So, but primarily these are the 3 main tools, and I think most of us already use these in our day-to-day life. We are very much well accustomed. We very much know how to implement these. Great. So after we've understood the data, the nature of the natures and the characteristics, we will then put it in the machine learning tool, and from that point of time, it's up to the high-level calculations, the big data, etc. All that happens. One caution I want to pass on to everyone, and this was also highlighted briefly in the module that we studied. there can be two different data sets. Both of them can result in the same descriptive statistical metric. This basically, I want to give you an example. It's not, I haven't put it up in the presentation, but I'm going to give you an example of two data sets. The first data set has just two data points in it, 40 and 40. So we just know these two numbers are part of the first data set. In the second data set, let's say we have 30 and 50. So now if we calculate the mean or the average of both the data sets, the answer will be the same. 40 and 40, average is 40. 30 and 50, average is also 40. So we should not always rely just on one statistical calculation. We should always have a counter on it. And for those who remember, in our module, it was also mentioned that the 2007-8 financial crisis it probably arose from just one of these miscalculations that Moody and Fitch or Standard & Poor's committed. They were allocating ratings to the various home loans, which later eventually turned into non-performing assets. But the way that they were doing is they were just allocating ratings based on only very focused calculations. They didn't consider that we should also probably look at standard deviation, or we should also look at how far is the score of this loan from the average of the industry. They just took the average of the entire book that they sold to the next party in the agreement. They just said that, okay, the average of these 100 loans is well above the security, well above the threshold, so it's safe to sell this security. They didn't consider that there were a lot of loans which were way below the average, and that's what resulted in the crash. A lot of those loans didn't pay up the money, and we all know what happened. That's it from me. Any questions? Happy to answer.
Thank you very much. That was nice and straightforward, a bit relatively.
It was very, kind of rough studying things, not much interesting. Anyhow, that was, part of it. And at a higher level, we need to understand those things. We'll move on. And the last thing that Abeer will share with us. So, Abeer, please start.
Okay, I'm gonna do the share screen. I need maybe Sumit, you can stop sharing, please.
I think I've stopped sharing.
Okay, so I'll retry. It takes me to something that I didn't. Okay. I'm technically challenged, it seems, huh?
Yeah, I think every time you have problem.
Yeah. Okay. So I don't want to show. Actually, I'm losing the entire thing. Okay, I'm getting this back.
Yeah.
Okay, we can see your screen now.
Okay, good. So I am starting to have things. I have to acknowledge that after listening to your presentation, I know how much technically you guys are savvy while I'm not. So I was confined a little bit with the learnings from our videos and handouts. And I'm gonna pursue, there seems to be a bit of overlap between Sumit and myself in terms of the points and inputs, but I'll pursue with looking beyond the summary statistics. And it seems that the entire thing is around the limitations of summary statistics that are already mentioned by Sumit. So the summary statistics do not imply the whatever same data. They could represent wide range of different data.
Abir, we cannot see
your
your
screen, slides.
your slides. Screen we can see, but slides no.
So it didn't open, it seems. Okay. I'm gonna stop sharing it. Do you see anything?
We can
Do you
see your
see?
screen.
You don't see the slides?
No.
So open the slide before you start your presentation. Before you start the screen sharing, open the slide.
I am already opening our screen sharing. It says that I'm.
Tajudeen is saying first open your slide, then share your screen.
Okay, I got it. Okay. So it seems that every time I delay you guys with this, huh? Do you see my screen?
Still the same.
I think you've got your slides on the other screen, and we see your folders. We see your Cambridge and old laptop, all those folders.
Abhi, you are using an Apple laptop, right?
Yes.
So just what I think the slide presentation is going on to the second screen. So just I think with the 3 or 4 fingers you can slide to the next screen, and there the presentation will be. Yeah, just shift the screen.
Okay, I'm shifting the screen, but it seems that you are not seeing the slides.
No, we are not.
Okay, that's very confusing actually. Is it something related to Apple or what?
No, it's not.
Just a quick thing. When you click share screen, you will get a lot of options like your folder, your presentation, everything will come. So you need to click presentation slide and then give share screen.
I did that actually. It didn't open. So.
Or you do share desktop if you have an option over there.
I don't share?
You share desktop.
I stopped the sharing, but when I reshare, I have different. Okay, how about now?
Yes.
Okay.
We are here.
Okay.
What you did this time?
I don't know. It just comes by like I thought I'm technologically challenged a little bit. So looking beyond the summary statistics is about the limitation that already have been mentioned by Sumit, that the same summary statistics do not imply the same data. They actually can have different data, and they sometimes conceal and hide a lot of good information. The message is do not just rely on them. We always need to dig deeper. And the same example that have been provided to us, what I want to highlight that it is because it is not an intervally even data, it created the pitfalls and the consequence to that, the financial crisis that have happened back in 2007, 2008. And it was described that there could be, and this is the claim of the banks, that there could have been created data rather than genuine or credible data. And what they described as a barbell shape, maybe you guys know that, but I was like curious to know what is it. So this is an investment strategy applicable to fixed income portfolio. And actually, it says that because of the barbell method, half of the portfolio contain both the long-term bonds and the short-term bonds. And they get, it's called barbell because there is kind of heavily weighted information or maturity timelines at both ends, while in the middle, there is almost little or nothing in the intermediate holdings. So this is the description. The conclusion is only rate the average things if they are on an interval scale. Not any type of information or data point can be used as average. And remember that the mean hides important differences. Moving to the normal distribution appears in situations where there is large number of independent yet similar and random events occurring. So they need to be independent, they need to be similar and random, and sometimes they are described as natural, like the heights of individuals in a community, for instance. But for a statistician, normal distribution can be described by two numbers, the mean and the standard deviation. And we are all looking at this graph of normal distribution, and it has a lot to say, actually. You all know that with the deviation, the standard deviation, we see most of the data are centralized in the middle, and with more deviation, less data. And the same graph of normal distribution, it shows the cumulative percentages and percentile. So it is highly beneficial in terms of statistical demonstration. And the best way to plot it is to use a histogram that shows the relation between the data points and the frequency. Now, sometimes the distribution is not normal, and sometimes we get bimodal distribution, or sometimes even a multiple distribution. Depends on the data we are having, where we demonstrate the modes, like in this case, the 3s and the 12s, more than one, either 2 or more. And actually, not necessarily those modes are identical in terms of frequency. So this is another way that could present the information. And that was exemplified in the case of Capital One's stock, where the stock came down because of two scenarios to explain the probabilities and demonstrating the two modes. What we needed, the take-home message, is that the Black-Scholes option pricing model used by Wall Street assumed a normal bell-shaped distribution, even for future stock prices. And this is definitely is not the case. We should not assume there is an orderly continued process in this world that can be described by a normal distribution. And the impact, it seems that is huge, actually. Huge movements are not reflective of a normal distribution. The coming question, why do we need statistics? And what questions are statistics answer for us? Do we get right information if we depend on the noise, which is standard deviation, versus the signal, which is obtained by the difference between the means? Things actually are not straightforward, and we need to make sure we are considering all variables, depending on which the amount of points representing by standard deviation. Actually, it's like analyzing the scenario. So the variables are, to me, sometimes are obtained even by brainstorming and then prioritizing. So it's not a straightforward mechanism. Here are examples of the cutoff values in different disciplines. In standard deviation, the p-value of social science is 0.5. In marketing, it's more liberal. P-value is 1 to 2. In medicine, it's 0.001. In certain domains of physics, you need 6 zeros after the decimal point for the p-value. And this is a difference of its accuracy and preciseness needed in that discipline. Last but not least, the effect size and correlation. There are two main questions for business leaders. What does it actually matter? And how much does the link discovered matter to the business? Regarding the first question, it's about measuring how big or small of a difference an effect is or it creates, related to the p-value and standard deviation. We need to see the difference between using the p-value. For instance, effect size of 0.2 implies 0.2 of standard deviation difference, which it kinds of mirror a small effect size. While if we can, it can be also represented by as percentage of variance accounted for. For instance, if we are using regression square 0.2, it means 20% of variance, which accounted for by the model, which is very large, relatively large effect size. This is all need to be put in mind. There are sometimes rules of thumb, and we need, even with the rule of thumb, decide whether it matters from a business perspective. And by showing different adverse, and we are having this kind of example when they studied the relation between cancer and the intake of processed meats. So there might be two adverse, both of them are demonstrated well by statistical measures, and they could carry significance even if the difference is as small as standard deviation of P equals 0.5. So the two adverts demonstrate there is a strong evidence of correlation between the processed meat intake and cancer, while the effect size, overall effect size, is small. So in those cases or similar cases, we need to show both evidences or both adverts. Moving to the correlation, which is looking for a linear relationship between two variables, people usually overestimate the correlation. And this is because the correlation works by percentages of variances accounted for, determined by squaring the correlation values. And we were provided by this, the correlation.com. It's a website for demonstrating more. We can play with it, various databases and their correlation automatically calculated. And there are instances for the correlation. If we look at it, this is to demonstrate how the variance and the correlation is kind of overestimated or augmented because of the square root, the square. So 0.2 correlation is 4% variance, while 0.5 is 25%, and 0.9 is 81%. And this makes a huge difference rather than looking at it from this kind of standard deviation p-value measures. So and from the video, it was kind of reiterated that going from correlation 0.2 to 0.3 is much easier than from 0.8 to 0.9 in terms of variance accounted for. The second question, how much does the link discovered matter to the business? And there are two types of business leaders. I think we can also classify ourselves. Those who dislike numbers, so they ignore the numbers, they avoid numbers actually, and they use their intuition. And those who think numbers tell them everything and lead only based on the statistics. Business leaders should use statistics and evidence to drive their decisions, but shouldn't be controlled by them. So we consider the numbers, we get the guidance by the statistics, but don't be slave to them, and we need to control the numbers rather than letting the numbers control us. By that, I would thank you.
Good one.
Thank you, Abeer. It's really nice.
Thanks, Abeer. Thanks a lot.
Thank you.
Guys, I think we are running out of time. So let's meet tomorrow. Some of us will be there and some of us new guys will join us. Thank you, everyone.
Thank you, everyone.
Hope to see you.
Just before we leave, I have a small request. Like, if anyone is like good in using the standard deviation and correlation, if he can give or he or she can give more insight into it, like how this can be used for the business purpose, I would love to hear from him. I want to learn that, but somehow I don't get through this thing, like how the standard deviation or the normal distribution can help us in interpreting the business information or like making the decisions, etc. So anyone, please.
I'm also with you to learn this one.
Okay. Actually, from my industry, we use it a lot in the medical researches. But I could understand from our learning and our module that it's totally different when you are using it for the business. So I would suggest that this request is put in the WhatsApp group definitely some of the colleagues there, they might have this kind of experience with the business itself.
Okay. Mustafa, can you help me with that?
Sure,
Since I
sure.
just keep scratching my head with these standard deviation and normal curve, I somehow don't get it. Like, man, okay, it looks very good, very nice, going like this, but how to use it and where to use it?
We will find someone to explain us. So let's look at it later.
Okay.
Thank you very much,
Okay,
everyone.
Thank
Thank you
you.
very much.
Bye-bye.
I want to
Okay,
see
bye-bye.
Tajudeen. Is he sleeping or he's awake now? Tajudeen,
I'm awake now.
you are awake? Okay. Well, I thought like Saurabh make you sleep, huh? Okay, anyway, it was nice,
All right.
huh?
Okay,
Okay.
guys. See you.
See you.
Thank you guys, thanks. Saurabh, please do share your PPT, huh?
Okay.
Thanks a lot.